Okay, so let's get some more rules. There's going to be some rules in this, but believe it or not, there aren't that many rules in probability at all. But man, the combinations can get out of hand really, really fast. Okay, first rule is let's talk about the probability of an event A or the probability of an event B. So think of this as if I have what's the probability of rolling a 6 or drawing a jack from a deck of cards. Now, the most important question when you answer these types of problems is, are the events mutually exclusive? Mutually exclusive. Another word for mutually exclusive is, I can't hear you, disjoint. Okay, disjoint means they can't happen, they don't overlap. They can't happen simultaneously. In other words, what I'm doing is I have a die in one hand and I have a deck of cards in the other. And I roll the die and I draw a card with the other. They don't overlap at all. So let's think about that. What I've got, if I think of this as a Venn diagram, I have two sets. I have the die set, and that's got 1, 2, 3, 4, 5, 6, and then I have the card set, and they don't overlap. There's nothing overlapping. Now you may say, wait a sec, but Ripley, what about the 1 of hearts? Because this would be ace through king of hearts, ace through king of spades, etc., etc. So this is ace through king 4 times. Okay, well, they're different outcomes. We're counting pips in this case, and we're looking at numbers on a card. So this 2 on the die is not the same as the 2 that you would draw out of here because the experiment is different. They are disjoint. They have no overlap. So the rule for that, for disjoint events, is you simply add the probability of A plus the probability of B. So in this case, the probability of rolling a 6 on one die is 1/6, plus the probability of drawing a jack is, well, there's 4 jacks in a deck, and there are 52 cards, so this is 4 52ths, affectionately known as 1/6 plus 1/13. What is that? 19/78, so 19/78. That looks about right. All right. So what is that? That's about a 1/4. Okay. Now this only happens when my sets are disjoint. Now, let's go back, let's go do cards this time. Let's do the probability of a heart or a jack. All right? Now, before we do this, let's build, we got a deck of cards, and I'm finding the probability that I draw a card, and that card is either a heart or a jack. Well, you've got the set that represents all the hearts in the deck, and then you have the set that represents all of the jacks. Now there are 4 jacks in here, but this intersection between these two sets is, as you can well imagine, the jack of hearts. There's a jack that is both, or excuse me, there's a card that is both a jack and a heart. Now there's 12 other cards in here that aren't jacks, and there's 3 other cards in here that aren't the jack of hearts. But the problem is if I apply this rule, this counting rule, or this probability rule, watch what would happen. I would say, okay, the probability of hearts plus the probability of a jack. The problem is that this card got counted twice. It got counted in the hearts, and it got counted in the jacks. So what we need to do is we need to subtract out the probability of the jack of hearts, the probability that it occurs at the same time. Does that make sense? Think about that for a sec. The jack got counted in the jacks, but it also got counted in the hearts. So there were 13, think about it this way, there were 13 out of 52 hearts, and there were 4 out of 52 jacks, but the problem is the jack of hearts got counted in both sets. So I have to subtract out one of those times that it got counted. All right, so stew on that for just a second. So what's that, 17, that's 16 52ths or 4 13ths. All right, in this case, a little bit less than 1/3. So what we need is a rule. So let's see, let's write my rule right down here. The probability of A or B, now in this case, we're not mutually exclusive. We have overlap. All right? The probability of A or B is equal to the probability of A plus the probability of B minus the probability of, now if we do set notation, it's the intersection. But you'll also hear this referred to as the probability of A and B. All right? So everything that these rules speak to depends on whether or not the sets are disjoint or not. Now, the conjunction that we want to play with here is or. I am saying the probability of something or something else happening. This, let's call these the or rules.